Hi everyone, and welcome to lesson 7-3, triangle similarity, angle, angle, side, 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 and side, angle, side. These are the three shortcuts that we have to showing that two triangles are similar. So let's take a look. So notice our first type of similarity is angle, angle similarity. In this type of similarity, we show that there are two pairs of congruent angles that correspond in our triangles. And if there are two pairs that are congruent, then we can say that the two triangles are similar using angle-angle similarity. Now, this one is very different from the ones we've looked at in the past because there are only angles mentioned in this one, not sides. The next one we have is side, side, side similarity. Now, think back to what you know about the sides of similar figures. It's not that they have to be congruent, they have to be proportional. So these two red sides that correspond have to be proportional, which means if I make a fraction with their two side lengths, it has to equal the fraction made by the green sides. And it also has to equal the fraction made by the blue sides. Okay, if all three of those fractions are equal, then we can say that our triangles are similar by side, side, side similarity. The last one we have is side, angle, side similarity. In this one, I have to show that the red sides are proportional and the blue sides are proportional and the two green angles are congruent. If all three of those things are true, that means that these two triangles are similar by side, angle, side similarity. So let's take a look at an example. Okay, in example 1, they want us to explain why the triangles are similar and write a similarity statement. So we don't actually have to figure out if they're similar, but we need to explain why they are. So in the picture, notice they've given us these two lines, these little arrow symbols, and those symbols mean that those two lines are parallel. So think through the three shortcuts we have and see if you can figure out which one is actually true for this. And then check your reasoning in just a minute. So what I realized was that they didn't actually give us any side lengths. So I can't use side, 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 or side, angle, side. So I went looking for congruent angles. Now, if you wanted to, you could use the vertical angles here in the middle, but I decided to just use one theorem, and that's the alternate interior angles theorem. We have this transversal right here. So that means angle S and angle T are alternate interior angles, and they have to be congruent because they're made by parallel lines with a transversal. Now I notice that PR is another transversal, so angle P and angle R are alternate interior angles, and they have to be congruent by the alternate interior angles theorem. So I have two pairs of congruent angles, making these triangles similar by angle-angle similarity. So you'll notice this bottom statement here is my similarity statement. So that's it for this example. It's time for you to try it. So start a Google Doc, and on that doc, you're going to do check it out number 1. You have to explain why the triangles are similar and write a similarity statement. So you're doing the exact same thing that I did in the last example. See if you can figure out why those two triangles are similar, and then write a similarity statement, and then come back for example 2. So in example 2, they ask us to verify that the triangles are similar. In part A, they gave us triangle PQR and triangle PRS. Now notice they've given us all of the side lengths for both triangles. So that means I should try for side, side, side similarity. So pause this video and see if you can figure out the proportions you should write and see if they actually are equivalent. And then come back here to check your work. Okay, so what I did is I did PR over PQ. Now notice in the names, PR is the first two letters and PQ is the first two letters in the other one. So I know that they correspond. And when I reduced my fraction, I got 3/2. Then I did RS which is the second two letters, over QR, which is also the second two letters. So I got 6 over 4, which is 3 over 2. And finally, I did PS, which is the first and last letter, over PR, which is also first and last. When I reduced my fraction, I also got 3 halves. Because all 3 of these gave the same fractions, I know that the triangles are similar by side, side, side similarity. Let's take a look at another one. So in part B, they asked us to find triangle JKL and JMN and see if they are similar. So in my picture, notice they've given me this side here, JK, and JL in the small triangle. And they've also given me enough measurements to figure out the length of JM and the length of JN in the big triangle. Now be careful about that, because notice this 6 only refers to LN, and this 4 only refers to KM. So notice they've given me information about 2 pairs of sides, but they haven't told us about the third pair of sides. So I can't use side, side, side similarity. So pause this video and see if you can figure out what you can use and attempt to show the similarity, and then come back to check your answer. Okay, so what I did is I found out that the length of JM is 6 units and JN is 9 units. So then I was able to make 2 proportions. JN is the long length on this side, divided by JL, which is the short length on this side. And that was 9 divided by 3, which is 3. And then I did JM, which is the long length on this side, divided by JK, which is the short length on this side. And that gave me 6 divided by 2, which is also 3. The last thing that I noted is that angle J is in both triangles, so it's congruent to itself by the reflexive property. So these 2 triangles are similar by side angle side similarity. Please note that the angle has to be the angle that connects the 2 pairs of sides. So I had side, angle, side. Okay, so it's time for you to try it again. In check it out number 2, you need to verify that triangle TXU is similar to triangle VXW. So pause this video and do that on your Google Doc, and then come back for example 3. Okay, so in example 3, they want us to explain why triangle ABC is similar to triangle DBE, and then find the length of BE. Now notice in this picture, it's very tempting to use side angle side because we have 1 pair of sides right here, another pair of sides over here, but wait a minute, they didn't give us a length on BE. So we really only know the lengths of 3 sides, but we need 2 pairs of sides and we don't have that. So we can't use side, side, side or side angle side. So that means we're looking for angle-angle similarity in these 2 triangles, and then we can use a proportion to find the length of the missing side. So pause the video and see if you can do that, and then come back to check your work. So what I figured out was that I have parallel lines, AC and ED, and they're met by 2 transversals, EC and AD. So C and E are alternate interior angles, and A and D are alternate interior angles. So they need to be congruent by the alternate interior angles theorem. So I know that these 2 triangles are similar by angle-angle similarity. Now another option there is to use the vertical angles here, angle ABC and angle DBE. So those are also congruent, but we only need 2 pairs, so I don't even need to say that. Now, for the side length that we needed to find, I said that BD is proportional to AB. And I can see that in the name. CAB comes first and DB comes first. I also know that BE, the second two letters, are going to be proportional to BC. So all I did was I wrote proportions with those side lengths, and then I filled in the known measurements. And then I solved it using a cross product. So I found out that X, which is BE, is 81. And that's the last thing I needed to do on that example. So you have one to try next. In check it out number 3, you need to explain why triangle RSV is similar to triangle RTU. And then you need to find the length of RT. So pause this video and do that. Put it on your Google Doc, and then open up video 2, for example 4.